Welcome to the podcast. Just to start with, I said in a previous episode that I'll be moving away slightly from the McCaslin disappearance pattern. I think after this, I'll go back to that. And I think not just only that, I think the true crime genre in general, I'm quite drawn towards. I think there's some very interesting cases out there that's not just tied to Neil McCaslin and the UFO sort of area. But I'd like to know what you guys think, because obviously this is almost a bit of a pivot for me. And I'll still do some of the UFO stuff, obviously, but I think I'm quite drawn to these strange missing persons cases. The more I'm kind of looking into some other ones outside the McCaslin disappearance pattern, there's some strange missing persons, some strange deaths and stuff like that. And I'd really like to touch on those and look into those further. So after this episode, I think I'll be going back to that kind of genre, and I think I'll pursue it a bit more. As I say, I think just even outside of the McCaslin disappearance pattern into further stranger sort of deaths and missing persons. But back to this episode then. This one's a bit tricky because it does feature UFO footage, which I'm sure you can look up, or I'm sure you've seen it before. It's the 2021 Syria UFO. It was released by the Weaponized podcast with Jeremy Corbell and George Knapp. So it's kind of tricky to imagine, but it focuses mainly on a few frames. I think there's about 15 frames or so, and one specific frame. So I'm going to put that frame as the thumbnail, just as a reference, so you can kind of see what I'm referring to. And there's one little section of it specifically, so I might try and zoom in on that, just so you know what I'm analysing when I look at this video. But yeah, like and subscribe. Thanks for listening. Enjoy the podcast. So this video is very interesting. It's from the Weaponized podcast and YouTube channel. Big shout out to Jeremy Corbell and George Knapp. Love all the stuff you do. So I jumped straight in. I'll show you the video. Now there's no sound to this, but just bear with me. I won't include it in the podcast for obvious reasons. If there's no sound and no video, I don't think you really get much from it on an audio. So yeah, we'll jump in and then we'll get analysing it. Yeah, like and subscribe and comment, everyone. I'm really grateful for the comments and everything as well. You know, it takes a lot of effort to do these kind of things, and just the little comments kind of make it worthwhile. The little thumbs up or something like that as well. It's brilliant, and I really do appreciate it. Okay, so if we analyze the actual video in slow motion, you can see what appears to be motion blur. But is this actually motion blur? So here we go. You can see the object as it moves. There's the extension, and most of this is just focused on this clip. These few frames, these 10 frames that I've got, because I think it shows quite a lot more detail in there than we realise. But is this actually motion blur? So for a start, we can see frame by frame that on the left-hand side is static, and the object extends 3 frames, then resets the trailing part of the craft and extends again. You know, this isn't normal motion blur. Motion blur wouldn't carry forward like this frame by frame. So I'll illustrate what I mean. You can see like the point there, and it extends to the right, and again it's done it again, and there the final scene, and this scene here with the 3 object image. That's quite interesting. We'll come back to that. The frame by frame motion blur can kind of in some situations do this. Don't forget, this is a military grade camera with IR. Under certain circumstances, it is possible, but it's still strange to have that consistent blur across multiple frames. So what about image compression issues? Well, this could be plausible as well. So essentially, does compression of a video create pixel objects that were never there? Well, it can. And the interesting thing here is if it is a compression issue, if the original footage has this same blur moving from frame to frame that's static across multiple frames, bearing in mind we're dealing with military grade camera hardware, then it wouldn't be a compression issue. So it'd be quite interesting to see the actual footage that's not being compressed. Also, how does compression explain that the object is pretty much half its vertical size and about 5 times its horizontal size when in this extreme acceleration? And excuse the I'm not sure if these are entirely in order, but you can see here's the original image, and here's the motion blur 3 dots, and again it kind of reverts back to different things. Sorry, they're out of order. It would take several failures all in conjunction for this to happen, such as compression, sampling, and or sensor behavior. Now, I go into these in more depth on the podcast, but for the video, I just give the conclusion, and the podcast is available if you want further information. Now, I know this involves image analysis, and I'll try and upload the images somewhere to the podcast so that you can see them and have access to it. I do have an X account, so I'll post them on there also. It's at Sheridan Study, SHERIDANS, and study. Sensor behavior, particularly in infrared systems, produces a different class of artifacts. These include after images or persistence, where a bright object leaves a fading trail, as well as blooming, where the object expands outwards in a smooth radial fashion. Sensor effects can also introduce motion smearing due to integration time and occasional global brightness fluctuations during calibration. However, these effects are typically smooth and organic, not sharply geometric. But sensor behavior does not align totally with the observations. Infrared sensors can produce persistence or after images, but these effects are smooth and decay gradually. Blooming from a hot object expands outward in a radial organic way, not in sharp angles or L-shaped geometry. And in the frames, we can see there is a slight L-shaped geometry to this. Sensor-induced motion smear is continuous and fluid and not discretely structured, and it does not produce a sudden disappearance after a fixed number of frames. You can see this in action though. On the left of the image in the frames, there is an element of sensor behavior. Digital sampling or zoom effects typically introduce pixelation or softness, along with anisotropic distortion, where one axis appears stretched or compressed. This can amplify horizontal elongation whilst reducing vertical detail. You may also see edge ringing or haloing around high contrast features, and instability in the object's shape from frame to frame during interpolation. Importantly, these effects tend to magnify existing artifacts rather than create persistent geometric features on their own. But also, digital sampling or zoom alone does not match the evidence. While it can stretch or distort an image and amplify horizontal motion, it does not produce a stable geometric shape that persists across multiple frames. Sampling artifacts tend to fluctuate frame to frame because they depend on interpolation, not memory. Crucially, they do not create fixed block-like structures or cause parts of an image to stick in place over time, like the L shape and rectangles we see in the frame shots. And finally, compression artifacts are the most characteristic. These include block-aligned edges, which can create geometric shapes like L patterns. They also produce temporal sticking, where parts of an image persist across multiple frames before suddenly updating, especially around keyframes. Other sides include edge quantization, where smooth shapes become angular, inconsistent motion across different parts of the object, and loss of detail in one axis, often resulting in horizontal smearing and vertical collapse. So these compression artifacts, however, match all the observed features simultaneously. Block-based encoding explains the geometric L shape through the pixel grid alignment. Interframe prediction explains why the feature persists across several frames before abruptly ending. Motion estimation errors explain the horizontal stretching and vertical loss of detail, while quantization explains the angular non-physical appearance. The sudden disappearance aligns with keyframe refresh behavior, where the image is fully corrected. So we know the FPS of a Reaper is about 30 frames per second. This video is about 24. Using some simple maths, we can calculate that some stretch would occur, but this would be at most of the form of about 5 times stretch of the image. The stretch we see is about 8.5 times stretch. So this would mean it would have to be motion plus compression plus frame conversion interaction. But this would have to persist across multiple frames and be a consistent error, which it is plausible. But another thing to note is this still. You can clearly see 3 defined objects in the frame, in this specific frame. And I'll put this in the thumbnail for the podcast listeners, as this frame is very important. As these are pretty well defined, there's a drop in vertical height, but also all 3 appear in the same frame. So when you switch frame by frame, it also doesn't seem to happen to the background information. The most reasonable cause for this would be a temporal recursive filter. So essentially the camera has stamped this object at 3 locations in which it's moved during this frame. And that's very interesting. It would be quite interesting to see the real uncompressed video to see if these artifacts are still present in them as well. But let's progress. So I've done some maths based on the information provided to get a speed of this object, as this is likely the object at 3 temporal locations. I also calculated the speed by using the 5 nautical miles, and the field of view was calculated based on the standard 4 times magnification of the camera on board the MQ-9 Reaper. Also use the gimbal elevation and altitude to narrow the field of view further. So I initially calculated the speed in the first 3 frames, or so, using the standard ways, and the speed seemed to be between Mach 1 and Mach 2 at around 0.25 to 0.5 degree field of view. So that's around 1,250 kilometers an hour to about 2,500 kilometers an hour, which is pretty impressive. Bear in mind that that was in 3 frames. Now, using the 3 object image, so there are 3 speeds to this image here we can calculate. There is the X directional, the horizontal speed, the Y directional, which is the apparent altitude or vertical, and the Z directional, away or towards the camera. Now, the X and Y is fairly reliable to calculate, but the Z directional is based on the dimensional drop from the first object to the second and then to the third. So it's the size reduction in these 3 stamps of the image. And whilst the Z direction was slightly more speculative, it is clearly moving away from the camera. So there's some element of here that, and I can delve into the fact that, you know, you can look at the fact that the image to the right of this, of the 3, is more defined. It gets smaller and stuff. There's certain camera effects that align with the fact that this is moving away. So the speeds listed are based on a percent reduction of the object size and combining these speeds together. Also, not to mention, to cause this sort of error on this camera system, it's got to be a guaranteed speed of at least Mach 1.2. Basically to trick it and give it that 3 stamp image. Again, I used the image, so for this, again, I used the image size reduction on the Z-axis for the calculation, just have to clarify that. And these are quite defined edges as well to do this. But from the motion exhibited in this single frame, it can be calculated in 3-dimensional motion that the object is moving at approximately between, get this, Mach 8 to Mach 15 at least as the floor speed. So this is accelerated even quicker than the initial 3 frames. So if we take the minimums here, Mach 1 to Mach 8 in 8 frames, so 0.24 seconds, that's about 1,000 G of acceleration. And bearing in mind, I've actually reduced these numbers. I've done the math a few times, and looking at the image reduction, field of view values, it had possibility of way higher than this, like above Mach 40 territory. So I've kind of reduced these to a level of normal, even though this clearly isn't normal. So even if we look at the energy release from 0 to Mach 8 in 0.25 seconds, if we assume the weight of a very light car, say about 1,000 kilograms, then the energy release would be about 3.76 gigajoules, or 0.9 tons of TNT, about 15 gigawatts. So in terms of the Artemis launch, we're taking the peak power in a 0.25 second window, because I think the Artemis launch is quite recent. It's quite a good comparison here. This was about 12.5 gigajoules. So this object would need 30% the peak power of Artemis for this maneuver. Bearing in mind, Artemis had 1,100,000 kilograms of propellant, was under slow sustained thrust and spread over thousands of tons and thousands and hundreds of seconds. This was from below Mach 1 as the estimated speed whilst it's being tracked to Mach 8 in 0.24. So this is near instantaneous acceleration. And this is just in these frames. What says it doesn't achieve greater speeds than this out of frame? So I say near or apparent instantaneous acceleration because, as I discussed previously, if it was true instantaneous, then it would require infinite energy. So if we assume not a total violation of our physical laws and there was some sort of acceleration, hence Mach 1 to Mach 8 after the quick motion started. The thing is, and I've mentioned it previously again, the material science needed for these speeds and forces is insane. You know, you think about the structural integrity of this thing and all the working parts within it for that to be sustainable. At Mach 8 as well, the drag effect is squared, and the air would be plasma. You know, and the heat scale on that is cubed. Not to mention there is no propulsion signature to this thing. Also, as an extra note, I calculated the size of the object, just a rough calculation, obviously within a margin of error, as this is just a bit of guesswork, but within reasonable ranges. The information, using the information that's provided on the screen, about 5 nautical miles. Therefore, given this data, an apparent IR image size of about 1.5 to 18 meters. And I understand this isn't verified and it's quite a large margin of error in just a rough calculation. But realistically, I think these ranges holds up to some level of normality, especially the accounts that we hear of this. So moving on. What if this isn't a camera artifact on the uncompressed video? So if you look at the uncompressed video and all this stuff still persists, and thus it is indeed recording some sort of, I don't know, maybe elongation of the craft or something, which I know sounds kind of crazy, but let's just do a bit of little hypothetical sort of physics, sort of, I don't know, a little brainstorm with this. This could appear at near light speeds due to Lorentz contraction, but as we calculate, the craft is very fast, but it's not quite Lorentz territory. So it would have to be about Mach 400,000 to experience about an 11% contraction. So what else could be happening? I previously discussed in the New Jersey orb video about the possibility the purple glow around the orb could be ionization of the nitrogen in the air. This could combine some principles of plasma physics, the Mondoloi research, and optical physics. Now, the Mondoloi research, obviously, I think that was Monica Reza. But I don't think it would describe this perfectly. The nickel alloy that was involved in that, I don't think really holds up to the kind of structural integrity that this craft would need, but it's still an interesting thought. So if we think about some of the theories that circulate, which say it's almost it projects almost like a gravity well, and the craft falls into it, and that's how it kind of as a means of propulsion. So it's not being so much pushed as more of a pull effect as the propulsion. So. And you combine this with the idea of the ionized region around the craft. So essentially, the radiation would warp and refract around the surface of an ionized region, causing a smeared and stretched, duplicated or distorted image. And this is kind of what we see here. So a craft that's utilizing this kind of propulsion system, it would explain the insane amount of energy and power required as well. If you have that technology to do that kind of thing, you would probably have the technology for this power. So from that proposed propulsion system of the craft falling into a gravity well, this would warp the space and time. It could look distorted from an observer's point of view. Whilst aboard the craft is shielded, if it's shielded correctly, would be unchanged. Especially at 5 nautical miles, I'd imagine you would see that kind of warping hypothetically, if that was a propulsion system. The non-compressed footage with all the relevant data behind it would be interesting to see, as I say, to see if it's got this smear effect. And also further to this, the elongation would actually occur in the direction of travel. And this is exactly what an observer would experience, that elongation in that direction. So here's a hypothetical scenario of this video based on a frame-by-frame object. The propulsion system creates a deeper curvature to the right. So the initial direction of travel. Then the image from the observer's perspective would be a stretched image to the right, almost like the left stays still. And then the image constructs to the right over time. Perhaps the gravitational field is moving with the craft. Radiation from different parts of the craft arrive at slightly different times to the camera, so that there is an asymmetrical temporal skew. So essentially a forward smearing and trailing or leading distortions, with an apparent elongation aligned with the direction of motion. The elongation would happen in the direction of the field gradient, which, as this is being utilized for propulsion, again would be in the direction of travel. Now, if the bending varies across the width of the craft, not just front to back, because we're dealing with a three-dimensional object, then the radiation from all sides would be warped as well. So suppose this craft is moving away from an observer, it would naturally appear smaller in height, as well as the gravitational distortion would affect the radiation emitted from the top and bottom, and the sides, so in height and width, all around the craft essentially. Perhaps with if it is moving slightly off, you would have an off-center focal point, when in a velocity vector not directly aligned with the camera, in the z-axis sort of thing. So if you think about the z-axis, as I say, going into, well, the positive will be coming out of the image and negative going into the image, and if it's slightly misaligned, you'd get like almost a blurring. So this can make the craft appear curved, arced, or kinked, like the L shape we see. So its trajectory would almost be left to right, heading away from the observer. So in the image, as it were, as well as some altitude shift, if it were going up, the kink would likely be at the top of the image, as this would be the focal point for the gravity well. So the radiation would be more strongly coupled here, and less likely to escape to the camera. Essentially, this is the most recent radiation that is still coupled to the craft's field. If it were lowering in altitude, then the kink would appear at the bottom, as this is where the distortion field is. So, and this is quite interesting, because if you think the distortion field would be if it was at the bottom and going down in altitude and moving away, it would be the other side of the craft from what we can see as the camera, and also lower down, and you would get an empty space below this mirror, which aligns with that L-shaped imprint on the IR camera. So it's almost like the thermal signature at the bottom and to the front of the craft, where the coupled field is strongest, as that would be the point of the artificial gravitational field. So this would be missing, and that's what we see. Further to this, and what I find the most important thing is the 3-image frame. Now, for about one frame, we observe a transition state. Old lateral signature moving left to right is now predominantly moving to a new away negative z-axis signature. This is very, there is very clearly no propulsion thermal signature of this object, as there is no diffusion or IR blooming. Well, as mentioned, if this is some sort of field manipulation propulsion, it would most likely pulse. In which case the emitted radiation may be totally absorbed by this effect, and what you see is the leftover radiation that was available to travel to the observer as it escapes the coupling craft propulsion system. So you would get these images and breaks in information, much like the early frames where it seems to jump. Not all the radiation emitted reaches the observer. Ultimately, a pulsed asymmetric propulsion field would produce a directional distortion envelope. Radiation emitted from the craft does not reach the observer continuously. It would escape in discrete, partially decoupled information packets. Older packets, having left the strongest field region, appear clearer and brighter. Newer packets remain more coupled to the field and appear dimmer, less detailed, and compressed or missing. This could create a 3-image frame like the one we see. Further to this, as the craft in this frame is now predominantly moving in the negative Z direction away from the observer, as illustrated in the picture, then the distortion would make the craft appear smaller and smaller as the warping of space-time is more equally spread around the craft, as it aligns more directly along the observer's Z-axis. Thus, the field envelope would amplify the reduction in the amount of radiation escaping towards the observer. Combined with the Doppler effect, we would see this object reduce dramatically, which is what we see. Now, to play a little devil's advocate, this is just hypothetical speculation based on rumours. I think it's just more of a fun thought experiment that we can just chuck in there and just think about. So we kind of know the object's moving away, as if it was moving towards the observer. The rear left object image would be more obscured than the right recent object. If it was actually, as it's actually moving away, the right or recent object is the one that's more obscured. So as it's moving away, obviously it will get smaller, but this is a dramatic amount of loss for one image of about 0.3 second exposure. And whilst this aligns with the extreme speeds, as I say, in one calculation I got over Mach 40, but we'll go for the floor speed of Mach 8. Is this all that's going on here? I also have to note it still doesn't really resolve the no blur joining these images. If it is continuous motion, should there really be some sort of blur joining these three images like this? Although I admit that it possibly could create these three images, that is a possibility. Also, IR blooming can produce multiple images, but not really defined like this. And again, there should be a blur, even a small blur, joining the objects. So for me, I feel that if the real footage was available for analysis, where the field of view was known, the exact pixels per capture, where there's no compression, all that kind of thing, a lot more could be said with certainty. I do think this is a very interesting footage and probably some of the strongest footage out there given its source. Don't forget it's been analyzed by US military intelligence who can't determine what this object is, and they listed it as a UAP or UFO to the rest of us. And they know their stuff. And actually, I feel that if the real footage was available, we could even probably surmise a bit more about the potential propulsion system in this thing. As in these, like we did in these frames, and especially the three object frame, you know, ultimately there's no thermal signature like indicating propulsion from this object. Perhaps if I had more time, I could review the whole footage frame by frame and try to analyze this more to explore possible propulsion, mechanisms. But this was all based just off these 10 or so frames. I can't remember, maybe 20 frames. So it would take me too long to do this, unfortunately. If I was to put this on the plausometer, I would say this would have to be about a 10 out of 12 for the plausibility that this is some tech which is either not commonplace, i.e. a black project or otherwise, or some other technology. Given the lack of propulsion and the acceleration that's involved in this, I'm more leaning towards the otherwise or otherwise derived. So perhaps some sort of reverse engineering, it's human tech is reverse engineered, or some, I don't know, unexplained otherwise technology. I wouldn't be surprised either way on this. I'm fairly certain it's some abnormal technology.